Okay, guys. It's been a while. It's been a while since I've had to record. I was supposed to record this video a while ago, but we're starting now. We're gonna go over the history of the atom, atomic theory. So if we were in a class, I had a box, and if I gave you a box and you cannot open it, how would you figure out what's inside? So you're not allowed to open it. But maybe there's, you don't know what's inside, but there's stuff inside. So how would you figure out what's inside the box if you can't see it? And that is the same thing with atoms. So how do we know that atoms have what they have if we can't see them? So what are the three parts of an atom? So you guys already know the three parts of an atom is the proton, the neutron, and the electron. So those are our three parts of an atom. But we're going to find out how they figured out where the different parts of the atom are located. Okay, so this is just background knowledge on what atoms are. So atoms are the basic unit of matter. So everything that has matter, everything in this planet has atoms. And atom comes from the word indivisible, meaning we can break it into parts. And it used to be thought that this was the smallest thing in the universe that cannot be divided. So we thought that this could not be divided, but we figure out later on that it actually can. So I asked this question during Zoom. If you are breaking a piece of matter in half, and then you break it in half again and again, how many times do you think you can do this? So how many times do you think we can break or rip a piece of matter in half? And it's just you asking this question. And the same question was asked, Democritus asked the same question, and he was the first person that believed in atoms. So he believed that if we kept ripping or dividing matter into half, we will at least we will come to this very, very small piece of matter. And he said, once we get to this point, we can't divide it anymore. So this cannot be divided into other parts. And that is where we come from. That's how we get the word atom, because atomos means indivisible, meaning not dividable, indestructible. And that's how we got the word atom. He was the first person to believe in atoms. A lot of people did not believe him. Another person believed that, his name was Aristotle, and he believed that the elements were the things that made matter. So earth, fire, water, and air. Everything was made from those elements. And no one believed him. And then we go 2,000 years later, and then we have Dalton. Dalton is going to be the first person that's going to come and develop a theory and rules in how atoms behave. So he came up with the same thing as Dalton. We have this. They call it the billiard ball model because it looks like an 8-ball, or like, those balls they use in pool. And he basically said kind of the same thing. And we're gonna find out what he said. Let's go to the next one. So he said that every single element is made out of atoms, which are indivisible. Meaning, like we said, indivisible means we can't break it in half. But that's wrong, because we know that we can break this in multiple pieces. We can break it in protons, neutrons, and electrons. So he was wrong about that. And let's keep going to the next one. The second thing he said is that all atoms of the same element are identical. But we just learned a couple days ago about isotopes. So not every single element is going to have the same mass, because we can actually change the number of neutrons. So that is where he is wrong again. So he's wrong about that too. We're going to keep going to his other rule. Another rule he proposed is that atoms of different elements are different, which is true. You know, different elements have different chemical and physical properties. They're going to have different mass. Atoms of different elements can combine with each other only in simple whole number ratios to form compounds. All that means is that if we are combining atoms together or different elements, they're going to be they're going to form in simple ratios. So for this water, there is 2 hydrogens to a ratio of 1 oxygen. So that's the simple ratio. We're forming a compound. This is basically that rule number 4. And the last rule he said was that chemical reactions occur when atoms are separated, joined, or arranged. However, atoms of one element are not changed into atoms of another element by chemical reaction. So he was wrong about this. I mean, yeah, no, but these rules aren't really that important. We'll go into the important stuff. I messed up on that. So we're gonna go, so we have Dalton, who said, you know, the model is gonna be a billiard ball. And now we have Thomson, and he discovered the electron. So he discovered the electron, and the way he discovered it is, we're gonna go and see what he did. So how did Thomson discover the electron? So this is the experiment he did. It's called the cathode ray tube. And the way he found out is that at the end of this, you could change the different metals. So you can change the metals, and then you can put you can activate the cathode, which is the positive charge, and it's going to go. So it's basically a ray. What he noticed is that every single time he kept changing the metals and the ray would go off, he put magnets on this. And he noticed that every single time the rays would go off, it will go and bend towards the positive side. So obviously we know that magnets are attracted to, if we have a positive magnet, it's going to be attracted to a negative, and if we have a negative magnet, it's going to be attracted to the positive. So he noticed that every single time he had this ray, it was getting attracted to the positive. So basically, this must be negative. And he kept changing every single metal. So he'll have another metal, and then he'll do it again, and then he'll have another metal, he do it again. But every single time he did it, it kept bending towards the positive. So he said that every single element must have a negative charge if it keeps happening every single time. So that is how he discovered the electron. So he observed that negatively charged particles were removed. Thomson reasoned that the atoms contain negatively charged particles, which he called electrons. And his model is gonna be this. So when we did it in class, people were calling it the pizza model. We got the muffin model. It's called the plum pudding model. It's a dish they have in England. We don't know what a plum pudding looks like, because we're in the United States. But this is the model. And you guys know that elements are neutral, meaning they have 0 charge. So that is why we know that they have electrons, but we still haven't discovered the protons. So all he did was he said that everything, because it is neutral, it must have a positive charge, but we don't know where it is, so it's just gonna be all over the place. And then we're gonna put our electrons, because we know there's electrons, scattered around it. So that is how we came up with this model. So we discovered the electrons, and now we have the plum pudding model. It's not the billiard ball model anymore. We discovered one component of it, and now we're gonna go into this model. So this is Ernest Rutherford, and he discovered the proton. He discovered the proton, and he performed this experiment called the gold foil experiment. Oh, he discovered the gold. He did the gold foil experiment. So what he did is, in this experiment, Let me change. It's not gonna change. So in this experiment, all he did was he put some positive rays. He put some positive rays going towards this gold sheet. And every single time, what he thought was going to happen is he thought it was just going to go straight through, like in this one. This is what he thought was going to happen. Because in the plum pudding model, because the stream is, they call it alpha particles, but they're just basically positive particles. He thought it was just going to go straight through because most of it's going to be positive. But what happened is that they started to bounce off. And he didn't think that was going to happen because we thought that the model was like the plum pudding with the electrons are, scattered and most of it is positive, but that didn't happen. So what they thought was there must be something kind of hard in the middle that is causing it to bounce off. Something hard in the middle that's causing it to bounce off. And that is how they thought, or they came up, or they found out that in the middle we have a positive charge, because what is, if we have a positive going and we have another positive, obviously they're going to repel each other. They're going to repel each other. So that is why it started bending towards different directions rather than it's just going straight through. So if we go back to the slide, so the results were that most particles went through, which was expected. That was expected, but some were slightly deflected, and some were deflected back and missed the fluorescent light. And why did that happen? Is because the alpha particles were hitting the small dense nucleus where we know that the proton is going to be located. And obviously positive and positive is going to repel each other. And that is how we found out that the proton is going to be in the nucleus. And then the reason that if the proton is going to be the nucleus, the electrons must be surrounding it. So conclusions, dense positive nucleus and negative electrons were moving around the nucleus. So most of the atom is going to be empty space because it just went through. So they discovered that the nucleus was positive, meaning that it has protons in it. So right now we went from this model, which is Thomson's with the plum pudding, and now we have the proton with the electrons going around it. And that is what we got right now. But that we don't stop there. We're not stopping there. We're gonna keep going. So the next thing that happens in the model is we have Niels Bohr, and he is going to explain energy levels. So whenever we have an electron, they are going to get hit by waves. But right now we're going over waves. You guys are going to see why all these things kind of add up. So the reason why this model happened is because in the Rutherford model, we can't have electrons moving around like this. We can't have them moving around all the time, because what happens is that if we have electrons moving around all the time, that means that they're emitting light all the time. And if they're emitting light all the time, that means that they're using energy. And if they're using energy, they're eventually going to die off. So they're basically going to collapse into the nucleus. So he was like, nah, that's not the way it is. So what he did is he came up with this model where we have energy levels. So once an electron is hit with energy, it's going to jump to the next energy. And then once it emits that energy, it's going to jump back down to its ground state. And that is why we're going over waves. But this is why certain elements give off a certain flame, because when you put that energy in there, it's going to emit light. And we're going to see his model on the next slide. So this is his model, and it's just the same thing. So these are the energy levels, and it's called the solar system model because it kind of looks like a solar system. So this is the electron, and it was hit with a charge. It moved to the next one, and now a photon is emitted with energy. Basically, energy is being emitted. But that's what he was trying to explain, because we cannot have an electron moving all the time like the other one. But that is not where we stop there. And this is the last model. This is the model we have right now. So if you guys saw my electromagnetic one, you guys would know that electrons act like waves. And if you guys know this dude and another dude named Heisenberg, you guys would know that electrons, you can't know the exact location of an electron, because not only is it moving, because it's a wave, waves have speed, but it's also going to be, it's moving around, it's also circling. So we can't really actually know where an electron is going to be, because if it's being circling around kind of like a planet and it's also acting as a wave, we can't actually know where it is because waves have speed. So what they came up with was these orbitals. So we can estimate based on the orbitals where they're going to be, but we can't ever determine where they're going to be. We can never know exactly where they're going to be, but we can guess and estimate based on math models and equations where they're going to be. And if we use orbitals, we can estimate where they might be depending on how many electrons they have. And that's it. That is the model of that's the atomic theory, and there's a video for you guys to watch. And we already did all this. Also, just a real recap real quick. So we got Democritus and Dalton with, you know, the ball model, the billboard, or whatever you call it, billiard ball model. And then we got Thomson with the plum pudding, because he discovered the electrons with the cathode ray tube. After that, we got Rutherford, and he discovered the proton. So we're gonna have this, and then we're gonna have the electron circling around it, because we know that mostly in the middle is gonna be empty space, and then at the end, we have Bohr. And Bohr is gonna give us our planetary one. After that, we got Heisenberg and Schrödinger with the quantum model. And that's all you guys need to know about that. So just recap real quick. But that's it.